A-Level Computer Science video with me, Mr Goff, from mrgoff.com. This video will focus on regular expressions. Regular expressions are another way of describing sets. Regular expressions allow particular types of languages to be described in a convenient shorthand notation. Regular expressions use meta characters to describe the members of a set. The most common meta characters and the ones you need to know are star for 0 or more repetitions of the previous item, plus for 1 or more repetitions of the previous item, question mark for 0 or 1 repetitions, meaning this is how you make something optional, a pipe, which is a straight line, which means an alternative, so we will give two alternatives inside some brackets with a pipe between them, or brackets to group things together. Any other regular expression symbols you see in an exam would be explained during the use of the question. The easiest way to make sense of regular expressions is to have a look at some examples. In this first example, A plus B star, this regular expression means a set that contains values where 1 or more A's are followed by 0 or more B's. This means that A, in fact any string that contains just all A's would be accepted, as well as AB, ABB, ABBB. In fact, any string that contains any number of A's followed by any number of B's would be accepted. This next regular expression, 1 bracket 0 pipe 1 close bracket star 1, describes a set where every member will be a 1 followed by 0 or more zeros and ones and finishing with a 1. So the minimum it can have is just 1, 1 with nothing in between. But it might have any number of zeros and or ones in between. So 1, 1, 1, 0, 1, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1. All of these would be acceptable values for this. Any number that starts with 1, ends with 1, and only has zeros and ones in between would be acceptable. A brackets A pipe B close brackets question mark B is a regular expression that describes a set where each value will have an A followed by 0 or 1 A or B's and then a B. This means it could have AB with nothing between, AAB with an A between, or ABB. This is the entire set that it describes. The final example is 1, 0 plus 1. This describes a set where every value will have a 1, followed by 1 or more zeros, then another 1. So this would include 1, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 1, 1, 0, 0, 0, 0, 1, and the pattern would continue like this. You might be asked to describe the members of a set based on a regular expression, or be given a particular value and asked whether it would particularly be a member of the set. Regular expressions and finite state machines are equivalent ways of defining a regular language. This means a regular expression can be displayed as a finite state machine, and vice versa. You'll need to learn how to convert between the two. If we have a look at our example of A plus B star, we can see that as a finite state machine, this means that when we start at state 0, unless we receive an A, the value is not going to be valid. So it will go to state 2 if it's a B, where it will remain no matter what other inputs it receives, because this will always be invalid. If it receives an A, it will go to state 1, which is an accept state, because a single A is an acceptable value. Any further A's it receives will keep it in state 1, where it will be accepted, because any string of A's is an acceptable value. If it receives a B, it will move on to state 3. This is also an accept state, because any number of A's followed by any number of B's is an acceptable value. If it receives a B, or any number of B's, it will remain in state 3 and continue to be accepted. If it receives another A, then it will cease to be an acceptable value, and it will move to state 2, where any further values will keep it in a state where it will not be accepted. A language is defined as a regular language if it can be represented by a regular expression. Therefore, a regular language is any language that a certain finite state machine will accept. That brings us to the end of this video on regular expressions. Join me again in the next video when I'll be taking a look at the Backus-Naur form. Use the resources at mrgoff.com to help you revise computer science, and until next time, it's bye for now.